From section 12.1, we learned that in order to study a population, first we must gather a random and representative sample. Once we obtain the data from that sample, we can begin to organize that data using a frequency distribution or a grouped frequency distribution. Then, tools such as histograms, frequency polygons, and stem and leaf plots give us tools for actually visualizing that data. Here in section 12.2, we're going to learn how to begin measuring that data. There's two types of measurements: measures of central tendency and measures of dispersion. And it is in this section that we'll focus on measures of central tendency. There are 4 measures of central tendency, and they're probably going to be familiar to you. They are the mean, median, mode, and mid-range. And we're going to learn each of them one at a time, beginning with the mean. Definition: a measure of a set of data, such as the mean, median, mode, and mid-range, is called a measure of central tendency, how the data tends towards the center. Now, there's 2 situations in which we'll need to find a mean: in an ordinary list of data, and also if we have a frequency distribution. So let's begin with the basic formula. Now, before you become intimidated by this notation, stop and think for a minute. How do you find a mean? Now remember, mean is another word for average. So to calculate an average, we're going to add up all of the data points and divide by the number of data points that we have. And that's what our formula is expressing here. X bar, the X with the line on top of it, we normally pronounce that X bar, represents the mean. This is equal to, now over here, I've got this capital Greek letter sigma, and I have an ordinary X without the bar. Now, the X represents the individual data points. Those are the things that I'm going to be adding up. So that big sigma is a symbol representing a sum. So that's telling me add up all of the data points, where n is the number of data points, or the sample size. You can think of it as the cardinal number of the sample space, the total number of elements that I have. So this formula with this notation represents the traditional way of finding an average. So if you want to see it in expanded form, X bar, the average, is equal to the sum of the data points divided by the number of the data points. So we can expand this sum as the first data point plus the second data point. We continue doing that until we get to the last data point. Once I find that sum, I divide by the total number of elements that we have. So let's give it a try. Example 1. The ages of the youngest singers ever to record a #1 single are given below. Find the mean age. Remember, mean is another word for average. So the mean age, which we'll call X bar, is going to be the sum of the data points divided by the number of the data points. So we need to add up all of our data points. So I'm just going to write them all down and add them all up. And then we're going to divide by the total number that we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when we enter this into our calculator, we do need to be a little bit careful. It's important that we put the numerator in a set of parentheses to make sure the calculator finds that first before evaluating the division. Now, another way to do that is simply one part at a time. You can add all of the numbers there in the numerator and find that result, and then divide that result by 10 as your last step. Okay, so if I do it all at once, I'm going to divide by 10. I would end up with 15.9 years old. And again, if you wanted to do that in 2 steps, you'd find that the sum of the numerator is 159. When we divide 159 by 10, we would get the same thing, 15.9. So the average age, notice in our list, is sort of in the middle of the list. That's why we call it a measure of central tendency. Now, the average is not one of the data points, but it is in the center of the data points. So that's a pretty simple approach, but if you have a frequency distribution, you got to think about how do we factor in the frequency. We're going to edit the formula just a little bit. X bar, which is the average, is equal to the sum of the products frequency times data point divided by the total number of data points. So F is the frequency of each data point. Let me show you how this works on the following example. The following data was obtained regarding the stress level ratings for college students. Find the mean stress level rating. So if we look at the data points X, students are rating their stress level on a scale from 0 to 10, 0 being least stressful, 10 being most stressful. And then the frequencies of those responses are listed in the second row. So if I were to sum those frequencies, I'd be able to figure out how many students participated in this study. So let's find the mean stress level for these students. We're going to find the sum of the product of the frequency times its data point divided by the total number of data points. So if I look at this chart, 2 students said that their stress level was 0. So I'm going to take frequency 2 times data point 0. So that takes care of the F times X for the first data point. Then I'm going to add it to that same aspect. 1 student rated their stress level at 1. So frequency 1 times data point 1. Then I go to the next spot. I'm going to add it up. 3 students said their stress level was a 2. And I continue this pattern all the way across the chart. Almost ran out of room there. And then I'm going to divide the whole thing by the total number of data points that we have. Now, as far as total number of data points, we're going to have to add up the frequencies to get that. So right here, we need to make the observation that the sum of the frequencies is how we obtain the total number for the average. So I'm just adding frequencies down here in the denominator. That's quite a bit of information to enter into the calculator, so I'm going to do the numerator and the denominator separately. So I'm going to begin by calculating frequency times data point, adding that up all the way across the numerator. One thing you'll find about the formulas in this chapter is they're pretty simple, but they can be a little bit tedious. So the total for our numerator looks like 975. Now, let's calculate the sum of our frequencies. Remember, the sum of our frequencies is going to give us the total number of data points, or the total number of students that participated in this study. Because it's more than 10, right? 0 to 10 gave me the stress level rating, and the frequencies tells me how many students chose those stress level ratings. 151 total. So the average stress level rating then is going to be 975 divided by 151. And we end up with approximately 6.5. We'll go ahead and round it to the nearest tenth. So our average stress level rating is 6.5. Notice 6.5 is towards the middle of the scale, right? A mean or an average is a measure of central tendency. So I would not expect the stress level rating that's the average to be greater than 10, less than 0. I would expect it to be somewhere tending towards the center of the data. So a mean or an average is a measure of central tendency. Now, this is reminiscent of what we call a weighted average. So each data point is weighted by the frequency. Notice over here there was a very large number of students that chose these higher ratings. So that weights the average. That is, it pulls the average closer to the upper side of the scale. Now, believe it or not, your GPA is calculated as a weighted average, or using the formula that we just practiced. For example, when calculating GPA, use the following weights. An A counts for 4 points, a B counts for 3 points, C counts for 2 points, D is 1, and finally F is 0. So let's suppose that your schedule for the semester consists of sociology, biology, music, math, and English. Now, each of those classes has a certain time value associated with it. Our contemporary math class is a 3-hour class. You may be taking a biology class that has a lab which gives additional hours. Each grade point is weighted by the number of hours that class requires. So let's suppose that you earn an A in sociology. So an A is going to be 4 points, and this is a 3-hour course, right? A C in biology, a C gets a 2, and that's a 3.5-hour course. A B in music, B gets 3 grade points. That's only a 1-hour class. So it's not as weighty on your average as, for example, that biology class. So it's more important that you study for biology and do well in that class because it's weighted more heavily than something like this music class in our example. And you got an A in math class, that's 4 points. Hey, good job getting an A in math. And then a C in English, a C is 2 points for 3 hours. And we want to calculate your semester GPA. Now, you may be familiar with this process. If not, I hope you learned something new here. So what we're going to do is sum the frequency times the data point. That is, the data point here is a grade point of 4, and it's weighted by 3 hours. The next grade we have there is a C, that counts 2 points, but it's weighted by 3.5 hours. Next we have a B for music, that's only weighted by 1 hour. A 4 in math, weighted by 3 hours. A 2 in English, weighted by 3 hours. So that's going to give us our total grade points. Now, we want to divide by the total number of hours for the semester. And the way we're going to find that is simply by adding the hours here in the denominator. 3 plus 3.5 plus 1 plus 3 plus 3. So from the numerator, we have 4 times 3 plus 2 times 3.5 plus 3 times 1 plus 4 times 3 plus 2 times 3. So the sum in the top is 40, and the sum of our hours, 3 plus 3.5 plus 1, 3 and 3, we took a total of 13.5 hours for that semester. So our GPA is calculated as the sum of our grade points divided by 13.5 hours. So we end up with a 2, and we're going to round it to the nearest tenth. So if I try to round to the nearest tenth, that digit goes up, causing also my ones place to go up. So we have a 3.0 for the semester. So again, that is a weighted average, which is related to finding an average for a frequency distribution. All right, we will move on to the next measure of central tendency in the next video.